Welcome back to another deep dive. Today, we're taking a look at something pretty fascinating and timely. I think a lot of people are talking about this dataset bias in medical AI. We've got some really cutting-edge research to dig into, hot off the press from March 17, 2025. But before we get into the specifics, let's set the stage a little bit. You might think bias in AI is all about obvious things like race or gender, right?
Right.
But
Yeah.
what if I told you there are sneakier forms of bias lurking in the data used to train these AI systems, and they could be affecting things like how skin lesions are diagnosed,
Yeah.
or even how mortality is predicted.
Yeah,
You know,
that's exactly right. These hidden biases can have huge consequences, especially when we're talking about healthcare decisions.
Okay, so
Mm-hmm.
dive into this research paper. It's titled Detecting Dataset Bias in Medical AI, a Generalized and Modality-Agnostic Auditing Framework. Kind of a mouthful. Potentially introduces a new method called G-AUDIT, which acts like a detective, sniffing out those sneaky biases in datasets. And get this, we're going to explore how G-AUDIT uncovered surprising biases in 3 very different medical applications: skin lesion classification,
Mm-hmm.
stigmatizing language in electronic health records, and even mortality prediction using data from intensive care units. So by the end of this deep dive, you'll have a solid understanding of how GIU works
Yeah.
and why it's so important.
Yeah, it's all about understanding the problem first. AI models are incredible at finding patterns, but they're only as good as the data they learn from. So if the data is biased, the AI will inherit those biases, leading to potentially unfair and inaccurate diagnoses or predictions.
That's like Stiddy did, teaching a kid to bake a cake with a recipe that calls for a cup of salt instead of sugar, right? No matter how good a baker they become, those cakes are going to be pretty awful.
Exactly, except in healthcare. A salty cake could mean a misdiagnosis, the wrong treatment plan, or even an unfair allocation of resources. The stakes are a lot higher.
That's a recipe for disaster, for sure. So how does GRD help us avoid these AI baking blunders?
GRD focuses on 2 key concepts: utility and detectability. Think of utility as how relevant a piece of information is to the task at hand. For example, if the AI is trying to diagnose skin cancer, knowing the patient's skin color might have high utility. On the other hand, their favorite ice cream flavor would have very low utility.
Okay, so utility is all about relevance.
Mm-hmm.
What about detectability?
Detectability is how easily the AI can pick up on a specific attribute from the data. Let's say you're looking at a digital photo of a skin lesion. The resolution of the image will be highly detectable, right? Or if you're analyzing text from medical records, certain keywords would jump out.
So utility is about how useful the information is.
So yeah.
And detectability is about how obvious it is.
Yeah.
Makes sense. But how do those 2 concepts help us uncover bias?
Here's where it gets interesting. When both utility and detectability are high, for an attribute that shouldn't be a major factor, it raises a red flag. It suggests the AI might be taking a shortcut, relying on an easy-to-spot clue instead of learning the truly meaningful signals.
It's like a student trying to cheat on a test by looking for patterns in the questions. Instead of actually studying the material, they might get lucky on that particular test, but not really learning anything.
That's a great analogy, and those shortcuts can lead to big problems. When the AI encounters new data in the real world, it might not be able to generalize its knowledge and could make inaccurate predictions.
Okay, let's get specific. Walk us through one of the case studies from the paper. I'm curious to see how this all plays out in a real-world medical scenario.
Let's start with skin lesion classification. The researchers used a large data set called ISIC 2019, which contains images of skin lesions, along with information about the patients, like their age, race, sex, where on the body the lesion was located, skin color, the size of the image, and even the year the image was taken.
Sounds like a pretty comprehensive data set. So what did GRDAD uncover?
This is where it gets surprising. The analysis revealed that the image height, width, and year the picture was taken turned out to be highly detectable and had higher utility than the patient characteristics, like age, race, or sex.
Hold on. How can the dimensions of a photo, or the year it was taken, be more relevant than the patient's actual medical information? That doesn't seem right.
Right. It seems counterintuitive. But what the researchers realized is that seemingly insignificant details, like image dimensions, can actually leak information about the camera used or the clinical site where the image was taken.
So the AI isn't magically diagnosing skin cancer based on the year the photo was snapped. It's picking up on these subtle cues that might be correlated with other factors.
Exactly. Different clinical sites might use different equipment, have different procedures, or even have different patient populations. And these seemingly harmless details can create spurious correlations in the data. correlations that the AI latches onto. Imagine, for instance, that one clinic tends to take higher resolution images, and they also happen to see a higher percentage of patients with a specific type of skin lesion.
Ah, so the AI might start to associate high-resolution images with that type of lesion, even though the resolution itself
Sure.
has nothing to do with the actual diagnosis. It's a shortcut,
Yeah,
a false connection.
precisely. The paper uses the term proxy to describe these detectable features. They're acting as stand-ins for other hidden information that the AI shouldn't be relying on. And this is exactly the kind of bias that G-AUDIT helps us uncover. It's like shining a light on those hidden corners where the AI might be cutting corners.
That's a bit unsettling. So what does this mean for the accuracy of the AI's predictions? Could these shortcuts be leading to misdiagnoses?
That's a great question, and it's one the researchers tackled head-on. They wanted to understand not only if these biases existed, but also how much they might be impacting the AI's performance, and that's what we'll dive into next.
I'm all ears. Let's unpack how they measured the potential impact of these biases. I'm sure our listeners are just as curious as I am to find out how much damage these shortcuts could be causing.
Yeah, they developed a clever method to gauge the impact. It involved introducing synthetic attributes with 100% detectability and varying levels of utility. Basically, they created a worst-case scenario where the AI was intentionally tricked into relying on a shortcut.
So they rigged the game to see just how much the AI would cheat and how badly its performance would suffer. That's a fascinating approach. What did they find?
The results were eye-opening. For some attributes, the worst-case performance drop could be as much as 0.2 in AUC. AUC stands for area under the curve, a common metric for evaluating AI models.
Okay, I know we have listeners who aren't data scientists.
Yes.
Break down what a 0.2 drop in AUC means in a way anyone can understand.
Think of AUC as a grade for the AI. The higher the AUC, the better the AI is at making accurate predictions. A drop of 0.2 in AUC means a significant increase in misdiagnoses or inaccurate predictions potentially impacting patient care.
That's a sobering thought.
Yeah.
It underscores the importance of detecting and addressing these biases. It's not just an abstract technical issue. It has real-world consequences. Okay, let's move on to another case study from the paper. This one delves into the world of text data, specifically electronic health records. Sounds like a fascinating deep dive into how language can reveal hidden biases.
Absolutely. This case study focuses on identifying something called stigmatizing language in electronic health records. The research zoomed in on 3 categories of potentially biased language: credibility and obstinacy, compliance, and descriptions of appearance demeanor.
Before we go any further, let's break those categories down for our listeners. Can you give us some concrete examples of what this kind of stigmatizing language might look like in a medical record?
Sure. Credibility and obstinacy refers to language that might cast doubt on a patient's account of their symptoms or portray them as difficult. Phrases like patient claims or insists that fall into this category.
Ah, so it's language that subtly undermines
Mm.
the patient's credibility
Yeah.
or paints them in a negative light.
Exactly. Then you have compliance language, which centers on whether a patient follows medical advice. Terms like adherent, non-compliant, or even refused are common examples.
I can see how that category could be problematic. It could easily slip into judgment about a patient's behavior instead of focusing on their medical needs and the challenges they might be facing. What about the third category? Descriptions of appearance demeanor.
This one involves language that focuses on a patient's physical appearance or behavior, sometimes using terms like disheveled, pleasant, or even drug-seeking.
Wow, that's a pretty wide range of language. I can definitely see how it could introduce bias,
Yeah.
even if it's unintentional. So what did G-AUDIT reveal about these categories when applied to real electronic health record data?
Here's where it gets intriguing. The analysis found that the clinical specialty of the physician was more strongly associated with the presence of stigmatizing language than the patient's race or sex.
That's a surprise. I would guess that a patient's demographic information would have been a stronger predictor. What might be driving that finding?
It really highlights the nuance of bias. Even if an AI isn't directly using race or sex to make predictions, it could still be picking up on biases reflected in different medical specialties. Think about it. Certain specialties might have established patterns of communication or documentation practices that are more prone to this type of language.
So it's not about intentional discrimination,
Yeah.
but rather ingrained patterns of communication that
Right.
can perpetuate bias. It's like an unintentional blind spot.
Precisely.
They found something quite striking in the credibility and obstinacy category. Remember how we discussed detectability how easily the AI can pick up on certain features. Well, the patient's sex was highly detectable in this category, even though it had low utility for the task itself.
That's right. And this discrepancy is concerning because
Okay.
it suggests the AI might be learning to associate certain language patterns with a patient's gender, even when those patterns aren't actually indicative of credibility or obstinacy. This could potentially lead to biased judgments down the line.
It's a bit like judging someone's intelligence
Yeah.
based on their accent,
Mm.
even though their accent has nothing to do with their cognitive abilities.
Perfect analogy. It's a subtle form of bias that can have real-world consequences.
Uh-huh.
Okay, ready to delve into our final case study. This one tackles mortality prediction in the ICU, a high-stakes application of AI if there ever was one.
Absolutely. This is where it gets really real. Tell us about the data set and what G-AUDIT uncovered in this life or death scenario.
This case study used a data set called LOMI3, which contains a wealth of information about patients in intensive care units. The goal was to see if AI could use this data to predict mortality, which is obviously a very sensitive and critical task. Let's focus on two key findings from the G-AUDIT analysis. The first is what I'd call the obvious shortcut. The fact that a patient's temperature was missing from their record was highly detectable by the AI.
Okay, but why is that a problem? Isn't missing data just a random gap in the information? How can that be biased?
You wouldn't think missing data could be biased, but it can reveal patterns in how information is gathered, potentially skewing results. In this case, temperature missing could indicate something about the data collection practices at different hospitals, or it might even be correlated with the severity of a patient's condition.
Ah, I see. So it's not the missing temperature itself that's predictive of mortality and what that missing data might represent.
Precisely. Now, the second shortcut, G-AUDIT identified, is a bit more subtle. The AI could very easily detect the use of certain medications, like dopamine, norepinephrine, and vasopressin, along with things like whether a patient was on a ventilator or receiving IV fluids.
Those seem like relevant factors for predicting mortality in an ICU. What's the issue here?
The problem is that these interventions are often linked to the severity of a patient's condition, rather than being direct causes of mortality.
So the AI might be learning to predict mortality based on how aggressively a patient is being treated, rather than on their underlying physiological factors.
Exactly. It's mistaken correlation for causation, which is a common pitfall even for human doctors. Imagine a scenario where a patient with a less severe condition receives aggressive treatment because of other factors, like their age or insurance status. The AI using these shortcuts might then incorrectly predict a higher risk of mortality based on the treatment they received, even though their underlying condition isn't as critical.
That's incredibly insightful. It really drives home how these subtle biases can distort the AI's judgment and potentially lead to inaccurate and even harmful decisions.
And that's precisely why tools like G-AUDIT are so crucial. They help us peel back the layers of complexity in these data sets and expose these hidden biases so we can strive to develop fairer and more reliable AI systems for healthcare.
This has been a truly eye-opening deep dive. We've learned that dataset bias is a complex issue that can creep into medical AI in unexpected ways, impacting everything from skin cancer diagnosis to mortality prediction. But before we wrap up, I want to bring it back to our listeners. It's one thing to understand the technical details, but it's even more important to grasp the real-world implications. So let's recap the key takeaways from this episode and leave our listeners with a thought-provoking question to ponder.
That sounds like a great way to wrap things up.
Here's what we really need to remember. Dataset bias is a serious issue in medical AI, and it can be much more subtle than we might think.
Yeah, it's not always about overt discrimination based on race or gender, These biases can lurk in seemingly insignificant details like the dimensions of an image or missing data points, or even the language used in medical records.
It's like realizing that the dust bunnies under your bed are actually sending coded messages. You never know where these biases might pop up.
Right. That's where G-AUDIT comes in. It's like a powerful magnifying glass.
Yeah.
Helping us see those hidden biases and understand how they might be affecting the accuracy of AI's predictions.
So we've got this incredible tool, but it's important to remember that the biases G-AUDIT uncovers don't necessarily reflect intentional prejudice on the part of the AI developers or the clinicians collecting the data.
Right. These biases often arise from systemic factors or ingrained patterns of behavior that we might not even be aware of.
Which brings us to a final thought-provoking question for our listeners. Knowing that these biases can lurk even in the tiniest details of our data, how should this change the way we think about collecting and using data for medical AI in the future?
Yeah, it's a question we all need to wrestle with. We need to move beyond simply amassing huge amounts of data and start thinking critically about the potential biases embedded in that data.
It's like realizing that the ingredients for that salty cake came from a biased cookbook. We need to examine the source of our data and make sure it's as unbiased as possible.
Yeah, and we need to develop more robust methods for auditing our data sets, for identifying and mitigating those biases, and for ensuring that our AI systems are truly fair, reliable, and trustworthy.
The future of medical AI depends on it. We can't just blindly trust these systems. We need to be vigilant and hold them accountable.
It's an ongoing process, and it requires collaboration
Yeah.
between AI developers, clinicians, and ethicists.
We need all hands on deck to ensure that these powerful technologies are used responsibly and ethically to improve patient care and advance the field of medicine.
Absolutely. This deep dive has just scratched the surface, but hopefully it's given you a new perspective on the challenges and opportunities presented by AI in healthcare.
And we encourage all of our listeners to check out the full research paper for a deeper dive into the technical details of G-AUDIT. It's a fascinating read, and will give you an even better understanding of this crucial topic.
And remember, stay curious, keep questioning, and never stop learning.
Until next time, happy diving.